everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry, and that has been the for class 11th here. As you know that we had done part 1 of NCRT, which is in the last classes that you can see from the playlist. That has been for the part 2. We had started with in today's class, and that has been the class 1 for the part 2 here. And in the same phase, this is we have to start discussing about the unit 8, because unit 7 we had done in the last class on the place. I will just tell you the name of the unit as well. Unit 1 we had done some basic concepts of chemistry. Unit 2 we have to do the structures of atoms. Unit 3 is the classification of elements and periodicity in properties. Unit 4 is the chemical bonding and molecular structure. Unit 5 is the states of matter. Unit 6 is thermodynamics. Unit 7 is equilibrium. And unit 8, which we have to discuss, is about redox reaction, which we have to discuss here in this class. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. In redox reaction, that where there is an oxidation, there is always reduction. So chemistry is essential a study of the redox systems as well. The same phase we discuss about the chemistry, that the chemistry deals with varieties of matter and change of one kind of matter into the other, and the transformations of matter from one kind into another that occurs through the various types of reaction. One important category of such reaction is redox reaction. A number of phenomena, both physical as well as biological, that are concerned with the redox reaction, and these reactions find extensive use in pharmaceutical, biological, industrial, and metallurgical and agriculture areas. The importance of these reactions is apparent from the fact that a burning of different types of fuels for obtaining energy for domestic, transport and other commercial purposes, electrochemical processes for extractions of highly reactive metals and non-metals, manufacturing of chemical compounds like caustic soda, operations of dry and wet batteries, and corrosions of metals that falls within the purview of redox process as well. And of late, that environmental issues that like hydrogen economy, use of a liquid hydrogen as fuel, and development of ozone hole have started figuring under redox reaction. On the same phase, we'll discuss about the next we discuss here in the redox reaction in the detail has been the classical idea of redox reaction, oxidation and reduction reaction here. So that is, we have classical idea of redox reaction, which is oxidation and reduction reaction, that we have to discuss here. So in the same phase here, originally the term oxidation was used to describe the additions of oxygen to an element or a compound because of the presence of dinitrogen in the atmosphere. This is status being near about 20%, and many elements that combine with it, and this has been the principle, that reason why they commonly occurs on the earth in the form of their oxides. The following reaction that will represent the oxidation process according to the limited definitions of the oxidation as well. So for the same, we have your, that is being 2 mg, which is in solid, plus O2 form of gas, and give you 2 mgO, that is in solid here. For the next, we have that's plus O2, it will give you SO2, that we have here. So for the same, we will have to discuss moreover related to it. And on the same phase here, in the reaction, the element magnesium and sulfur that are oxidized on account of addition of oxygen to them Similarly, the methane is oxidized owing to the addition of oxygen to it, and that we have CH4 gases plus 2O2 gas will give you CO2 in the form of gas plus 2H2O, that is in the form of liquid. Where a careful examination of the reaction in which the hydrogen has been replaced by oxygen that prompted chemists to reinterpret oxidation in the terms of removal of hydrogen from it, and therefore the scope of the term oxidation was broadened to include the removal of hydrogen from a substance. The following illustration is another reaction where removal of hydrogen that can be cited as an oxidation reaction, and for that it will be 2H2S plus O2 in the form of gas will give you 2S in solid plus 2H2O in liquid. As knowledge of chemists grew, it was natural to extend the term oxidation for reactions similar to which do not involve oxygen but other electronegative element. The oxidation of magnesium with fluorine, chlorine and sulfur etc. that occurs according to the following reaction, which is being in the form of Mg solid plus F2 gas will give you MgF2 in solid, and another is Mg solid plus Cl2 in the form of gas will give you MgCl2 in the form of gas here as well. And on the same phase we go ahead with the detail about it, which is being the Mg solid, it will be sulfur, give you Mgs in the form of gas solid here. So for the same, that interpolating the reactions that within the fold of the oxidation, a reaction that encourages the chemist to consider not only the removal of hydrogen as oxidation but also the removal of electropositive element as oxidation. So thus that they are forming the reaction here in the form which is being for Fe CN6, it is in aqueous plus H2O2 aqueous will give you 2K3 Fe CN6 aqueous plus 2KOH, which is in aqueous. So here that is being interpreted as an oxidation due to the removal of electropositive element potassium from potassium ferrocyanide, and before it changes to the potassium that is ferricyanide. And to summarize that the term oxidation is defined as the addition of oxygen electronegative element to the substance or removal of hydrogen electropositive element from the substance as well. In the beginning, the reduction was considered as removal of oxygen from the compound, and however the term reduction has been broadened these days to include the removal of oxygen here, where in the same phase we talk about it, and that what we'll have to discuss here further, which has been about these days to include the removal of oxygen electronegative element from the substance or additions of hydrogen electropositive element to the substance as well. Here for the same, that according to the definitions that has been given above, that the following are the examples of the reduction process we have, which has been 2HGO solid in the presence of heat, it will give 2Hg solid and Hg liquid, and it will give you plus O2, which is in the form of gas here. So that has been the removal of oxygen from the mercuric acid, and that has been 2FeCl3 aqueous plus H2 form of gas, 2FeCl2 aqueous plus 2HCl aqueous that we have. So for the same, that the removal of electronegative element, that is chlorine, from ferric chloride, it will form in the form of CH2 double bond CH2 gas plus H2 gas, give you CH3 bond CH3 gas here. That is addition of hydrogen, it will give you HgCl2 aqueous plus SnCl2 aqueous, give you Hg2Cl2 solid plus SnCl4 aqueous. So that has been the addition of mercury to mercury chloride. In reaction, that simultaneous oxidations of stannous chloride to stannic chloride is also occurring because of the addition of electronegative element chlorine to it, and it was soon realized that oxidation and reduction always occur simultaneously, as will be apparent as re-examining all the equation that is given above, and hence the word redox was coined for this class of the chemical reaction as well. So we talk about the question here, and that will discuss the first question of the session as well, and that has been the important one, of course. So we go ahead for the same. Let's go ahead for the question here. So the question we have is, that has been that in the reaction given below, you have to identify the species undergoing the oxidation and reduction. So we go ahead for the same. So let's find it out. In the reactions given below, identify the species undergoing oxidation. So for the same, that will mean the oxidation, that is, so the oxidation and reduction. So first equation we have H2S, which is in the form of gas, plus Cl2 form of gas, it will give to SCl in the form of gas plus S that has been in solid. So for that, here that H2S that is being oxidized because a more electronegative element chlorine is added to hydrogen. A more electropositive element, that is being hydrogen, has been removed from S here. So chlorine is reduced due to the addition of hydrogen to it, and that is the reason that we have to go ahead for undergoing the oxidation and reduction. So yes, I will write it down for you all so that you can remember it, and you can just write it down as well. H2S is oxidized because a more electronegative element, chlorine, is added to hydrogen, or a more electropositive element. Hydrogen has been removed from S, and chlorine is reduced due to addition of hydrogen to it. So that we have here, and now we go ahead for the next equation, and that we have the second equation here. So the equation we have here, 3Fe3O4 3Fe3O4 solid plus 8Al solid will give you 9Fe solid plus 4Al2O3 solid that we have. So for that, here that aluminum is oxidized because the oxygen is added to it, and ferric oxide, that is Fe3O4, is oxidized, is reduced because oxygen has been removed from it. So that we will be going to write it down for you. Aluminum is oxidized because oxygen is added to it, and ferric oxide Fe3O4 is reduced because oxygen has been removed from it. Now we talk about for the third one, which we have here, and that we have to talk about the third equation as well. And so that we have, which has been 2Na solid plus H2 gas equals to 2NaH solid here. So we go for the same. So we go for the third one, and that is we have 2Na solid plus H2 gas will give you 2NaH solid here. So for the same, it will be your that with a careful application of the concept of electronegativity, only we may infer that the sodium is oxidized and a hydrogen is reduced. So in reaction third, chosen that here is prompts us to think in terms of another way to define the redox reaction as well. So that application of the concept of electronegativity, only we may infer that sodium is oxidized and hydrogen is reduced. Okay, so that what we'll have here. And on the same page, we talk about moreover related to the another topic that we have to discuss is about redox reaction in terms of electron transfer reaction as well, and that has been the important, of course. So we go ahead for the same, that is the another topic. Redox reaction in terms of electron transfer reaction. So for the same, we have to go ahead, and that we have already learned that equation about 2Na that we had talked about in the starting only, that is 2Na solid plus Cl2 gas will give you 2NaCl, which is in solid, that has been the salt we are using for food, and that is 4Na solid plus O2 gas will give you 2Na2O solid. These were the ionic compound they are formed, and then 2Na solid plus S solid, it will give you Na2S solid here. So that are redox reaction, because in each of these reactions that sodium is oxidized due to the addition of either oxygen or more electronegative element to sodium. Simultaneously, chlorine, oxygen, and sulfur that are reduced because to each of these the electropositive element sodium has been added. From our knowledge of chemical bonding, we also know that the sodium chloride, that sodium oxide and the sodium sulfide are ionic compound, and perhaps better written as is Na plus Cl solid, and then Na plus 2 which is O2 solid, and Na plus 2 S2 minus here. That was the same that has been written in a better way. And the development of the charges on the species that produce this that suggests to write the equations we formed here. And so we go ahead for the same. So it will be your 2Na solid plus Cl2. We had written this only, but it in a different way. 2Na plus Cl minus solid. So this, in this, as you can see, to Na that has been loss of 2 electron. So it has been loss of 2 electron, which has been your oxidation, and in that for Cl it is gain of 2 electron, which has been your reduction. We talk about for the another equation that we have is your 2 NaS plus O2, which is in the form of gases, will give you Na plus 2 whole twice O2 minus gas, and that has been here from this, that has been the loss of 2 electron, and in that gain of 2 electron. The another we have here is another one, which is 2 NaS plus solid S, give you Na plus 2 S2 minus in solid. That will give you, here it is, will be your, in this, loss of 2 electron, and here it in this gain of 2 electron. So that's for the same we have here, and on the same phase we talk about it. But here for the same, that for for convenience, each of the above process that can be considered as two separate steps, one involving the loss of electron and the other is the gain of electron. As an illustration, we may further elaborate one of these says that the formation of the sodium chloride, and for that it will be your 2Na solid plus, that will give you 2Na plus gas plus 2 electron, or you can say that Cl2 again the form of gas plus 2 electron, it will give you 2Cl minus gas here. So in the same, that each of the above step is also called of half reaction, and that which explicitly shows the involvement of electron, and some of the half reaction that gives the overall reaction. So it will be your 2Na solid plus Cl2 gas, it will give you 2Na plus Cl minus solid, and or you can say that 2Na Cl. So for the same here, that the reaction that suggests that half reaction that involve loss of electron are called oxidation reaction, and similarly half reaction that involve the gain of electron are called reduction reaction. It may not be out of the context to mention here that the new way of defining the oxidation and reduction has been achieved only by establishing a correlation between the behavior of species as per the classical idea and their interplay in electron transfer change. In reaction to sodium, which is oxidized, act as a reducing agent because it donates electron to each of the element that interacting with it, and thus help in reducing them. So chlorine, oxygen, and sulfur that are reduced and act as an oxidizing agent because these accept electron from sodium. And to summarize, we may mention that here, so I just write it down for you all so that you will be gone through with that and you will be getting it out each here in a detail. So we go ahead. for oxidation, and so the oxidation, what you can define here, for reduction, how you can define it, and for oxidizing agent, and another one is your for reducing agent. So for that, oxidation is loss of electrons by any species, and for reduction is gain of electrons by any species, and for oxidizing agent is your acceptor of electrons, and here it is, the reducing agent is your donor of electrons that we have here. So the rest we'll discuss in the next coming class. And other than chemistry, we had done your chemistry part 1 for class 11th, that is and for class 12th as well, and that has been your the unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, with the conversions, logarithms and antilogs as well. We had dealing with ER diagram, we are dealing with English vocabulary, we are dealing with PHP interview questions, we are dealing with the general knowledge and facts about the countries as well. In terms of it, we had started with physics part 1 for class 11, and we had even though started with physical world as well. You can go ahead. Other than that, we had started with quantitative aptitude. In that, we had done your general mental in arithmetical ability, we had done operations on numbers, as dependency of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, synthesis, percentage, profit and loss. In terms of chemistry, talking about it, we had dealing with reasoning, and that we had done your verbal reasoning, that we had done general mental ability and the logic reasoning. In non-verbal reasoning, we had done your series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completion of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, practice question set as well. In terms of coming towards chemistry part for 11th, that part 1 we had done, that is in the unit 1 is your some basic concepts of chemistry we had done, structures of atom, classification of elements and periodicity in the properties. Unit 4 is your chemical bonding and molecular structure. Unit 5 is states of matter. Unit 6 is thermodynamics, and unit 7 is your equilibrium that we had done. And today's in part 2, which we have to cover up for class 11th, has been CRT, and that is unit 8 we had started with, which has been the redox reaction. We have to cover up the classical idea of the redox reaction, oxidation and reduction reaction. A redox reaction in the terms of the electron transfer reaction, oxidation number, redox reaction and electrode process. In unit 2 we have to cover up the hydrogen, which in the unit 9 we have to cover up the hydrogen, that is the positions of the hydrogen in the periodic table. Then your dihydrogen, which is H2, preparation of dihydrogen H2, and that is properties of dihydrogen, hydrides, water, hydrogen peroxide, H2O2, and heavy water, which is D2O, and dihydrogen as a fuel as well. In unit 10 we have to cover up the S block element, which is being group F1 element, alkali metal, general characteristics of the compound of the alkali metal, anomalous properties of lithium, some important compounds of sodium, biological importance in sodium and potassium, group 2 elements, alkaline earth metal as well, and general characteristic of the compound of the alkaline earth metal, ammonium, anomalous behavior of the beryllium, some important compounds of the calcium, biological importance in the magnesium, calcium, and that the p block element we have to cover up, that is the group 13 element, the boron family. Important traits in the anomalous properties of the boron, some important compounds of the boron, use of the boron and the aluminium on their compounds, group 14 elements, the carbon family, the important trends in the anomalous behavior of the carbon, allotropes of the carbon, some important compounds of the carbon and silicon. Unit 12, we have to cover up the organic element, which is in the some basic principles and technique. We have to cover up the general introduction, tetravalence of the carbon, shades of the organic compound, structural representation of the organic compound, classification of the organic compound, nomenclature of the organic compound, isomerism, fundamental concept in the organic reaction mechanism, method of purification of the organic compound, and qualitative analysis of the organic compound, quantitative analysis as well. In unit 3rd, we have to cover up the hydrocarbon, which has been the classification, alkanes, alkynes, aromatic hydrocarbons, and carcinogenity and toxicity as well. In unit 4, we have to cover up the environmental chemistry, where we have to cover up the environmental pollution, atmospheric pollution, water pollution, soil pollution, industrial waste, strategies to control the environmental pollution, and the green chemistry as well. So here we're going to end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.